So what we will do here, and to set expectations with everyone, we have about 80 slides here. We have multiple demos. I'm going to blow through some stuff incredibly quickly. I'm going to skip a few things that I was going to talk about, the real sort of level 100 beginner stuff entirely, because I didn't know what the caliber of the audience would be. But given we've only got a few people here, and I know quite a lot of you, let's just skip straight to the meat of it. And if we come up a little early, that's perfectly fine. We can get on with any side conversations or anything like that, or questions that may be created during the session. My name is Charles Featherson. I'm the Director of Product Management for Postgres at Microsoft. So I look after flexible server, single server, which is on end of life, all of our open source engineering that we do, whether it's Citus or actually a laundry list of other open source projects, pgcopydb, all of that effectively rolls up into me for product management in some way, shape, or form. What I want to start with is an interesting topic that I think is, who are we actually building Postgres for? Right? And this is actually, it was funny, it was a question that I was asked by someone at a booth earlier today. Is Postgres for developers or is Postgres for the enterprise? The reality is it's both. And you can't split them, and one will become the other. It's not to say that there aren't developers working at enterprises who want new features. It's not to say that there aren't developers who start building code and one day need to turn that into a production system. And so you can't really split these two. Everyone has seen the data that says Postgres is the developer's database of choice. The line graph is kind of cool in the sense that Postgres is at the top of the chart. But what's interesting is if you look at it historically, Postgres was actually running equal with MySQL last year and was about 3% behind MySQL the year before. And on a scale of 1 to 100, moving 8% in 2 years is material. Exactly why MySQL's come under so much pressure is anyone's guess. Don't really know. But I don't foresee Postgres slowing down, just given the appetite we're seeing for it in the market. So what do developers look for? I've developed things before. I look for a lot of extensions. Postgres has this wonderful extension model that in many cases I can even write my own code and start to run it closer to the database. They want cost effectiveness, ideally free, but if you can't have free, then at least really, really, really cheap, where I can just write and compile my SQL into. They're looking for integration into ecosystems, and particularly they look for integration into Azure. The biggest gaps that we get feedback from customers on is where we need to integrate into other components of Azure, right? And I want to do all of them, don't get me wrong. I just need customer help or partner help to stack rank the ones that are important. Which one do we do first? Probably obvious, Azure Storage. The one that we just announced at Ignite this week, OpenAI. And then there's a laundry list, probably starting with some kind of like event hubs or change feeds or something else that we haven't thought of yet. They want the new shiny stuff. I call it latest Postgres features, but let's not pretend it's anything but the new shiny stuff. Postgres 16 comes out, and I'm running my Postgres in Azure. I want Postgres 16 in Azure yesterday. AWS actually do a relatively good job, and credit to them for bringing pre-release versions of major versions into the RDS ecosystem quite well. I think that's something that we need to look at in Azure. But what we put a ton of energy into this time around was getting Postgres 16 into a generally available supported model, which we did at Ignite as well. And that was 2 months after the community announcement, which to my knowledge is faster than any other hyperscale cloud provider did it. And we do it because there are customers out there who run their Postgres estates on flexible server on Azure. And that's what's been signed off by their security teams, their IT teams, compliance teams. This is where you can run your Postgres. And if we then lag in bringing major versions, it is not good for anybody, particularly the customers, right? And so we want to make sure that you've got the new shiny. We don't expect you're going to run production systems on day one of shipping it. I wouldn't either. But you want the bits, you want to start playing them with them, you want to start testing them, and you don't want to be blocked for 6 months while we get it into an Azure ecosystem. And then finally, tooling and communities. Because we're fundamentally hosting open source Postgres, all the tools just work. The demos I run will be out of pgadmin. You can run pSQL, you can run any tool you want. Everything just works. This is fundamentally what a developer needs at their fingertips to write their first line of code. Enterprises, on the other hand, I think we all probably know the list. I need Active Directory, or Entra as it's called. I need to manage my own encryption keys. I need Private Link, which we just did at Ignite as well. I need geo redundancy. I just need the laundry list of enterprise features that mean I'm going to be available, I'm scalable, I'm secure. And it's a finite list. Actually, it doesn't extend too much beyond this list. And I feel like right now we've got all of the big bases covered in Flexible Server. We're certainly not seeing any blockers that we're used to with enterprise customers. There's a little fit and finish on a couple of these things, but this is what enterprises need. So there is one other thing, and it's the universal feature that the entire world wants. Anyone want to guess? Just quickly? I'll give you a hint. It's performance. No one buys slow databases. In fact, I don't remember the last time I saw anyone evaluate a database where they didn't drag races against some other database, right? That's how people, it's a defensible position to take on a database. You cost the same and you're less performant than that one, or more performant than that one, what have you, right? That's a really easy way to make a decision. And so we invest very, very heavily in the performance of the database, and it was one of the major features that we announced at Ignite this week. And so what does this lead us to? Well, it leads us to the headline slide that we used at Ignite this week, which is Postgres is AI ready, where our developers want to start building these new AI-enabled apps on Postgres, and it's ready for enterprise applications. Right? Whether that's a statement around security or compliance or the ability to hook into other ecosystems, we feel that we've got a very complete package now in Flexible Server. And fundamentally, it sort of looks like this. You've got all of your availability, recovery, security, what have you on the enterprise side, but this is not binary. Like this all just melds together, right? But for the sake of creating some separation on why we're picking each of these core areas to build against, this is how we think about the requirements of each of these personas. So, what do you announce this week? We did Premium SSD v2, 4.5x higher throughput than SSD v1 that we were using. I would welcome anybody in the room or anybody that's listening to this recording in future to go run your workload on the preview version of SSD v2, test it, don't put it in production. We've got some other things that we need to finish with respect to encryption of the disks, availability, but if you just want to do a sheer throughput test and look at the upside that you can get from v2 versus v1, I think you will be very, very impressed, right? We ran a benchmark internally a couple of weeks ago where we looked at v1 versus v2 disks. We did a full code diff, actually, on all of the server parameters between the two machines. These were like for like. We couldn't make it more honest, even with ourselves, and that we did that to produce this slide. And these were the numbers that we produced. So this is not an incremental bump. This is a 4.5x bump, just running TBCC on HammerDB. So these are in preview today in a subset of regions. We'll roll them into as many regions as the storage team will put the disks, but they're not in all Azure regions yet. The other benefit of this, and what contributes to the throughput, is a reduction of 45% in the latency of actually running a given query as well. And I'll show you a demo a little bit later, I think so, of doing this. But basically what you'll see is that a brute force sort of loop of inserting 30,000 or so records has a radically lower latency. It'll show these exact numbers actually, compared to what it was previously. Come on in. The Azure AI extension, headlined actually in Claire's, who just walked in, keynote demo a couple of days ago, shows how we use the extension model in Postgres to hook into the standard APIs for Azure Open API and give you a SQL-based interface for passing data to Azure OpenAI, using the models that are there, and returning an embedding back to the database. Everyone's talking about embeddings, like embeddings here, vectors there. Very few people have ever actually seen an embedding or can really sort of relate to what it is. So I built a slide with an embedding. This is it. This is an embedding. We're going to use this in one of the demos today, but as an eye exam, I can tell you the top left one says 0.00915 something, right? It's a lot of data, right? I think it's generating one of these for each row in the database. And so be warned that your data volume may grow if you start to store embeddings per row for a large table that has text data. Not to say you shouldn't do it, you should absolutely do it. It's the best semantic search you can get. but it's not a lightweight amount of data that you're producing. If you want to know sort of why it needs so much computational work to generate these things, that's a good example. But what this AI extension does is it allows you to parse the data, get this back, store it in the vector type in Postgres, index it, and then start to do semantic search. And we'll spend a lot of time on that a little later in the session as well. All right, let's go back to where we were. We reduced scaling time by 95% at Ignite. Scaling, regrettably, used to take longer than it should. It used to take in excess sometimes of 10 minutes to scale compute and storage combined. That's 10 minutes of downtime. Now the downtime is thereabouts 30 seconds. We typically see it being under 30 seconds, so I've put that on the slide. We have ambitions to lower this even further. I hope to be at Build in May next year, if not even slightly earlier, explaining that we've been able to lower this time even further. But once you get within 30 seconds, and folks may or may not agree with this, once you're under 30 seconds, then your apps should absolutely be sufficiently tolerant to handle a blip like this. Whether it's an outage or a network blip or any other blip, 30 seconds I think is reasonable in the app, but again, we'd like to get it down. We did another feature for multi-region disaster recovery, which enables you to manually fail over your Postgres flexible server to another region under a single virtual endpoint. That means no application change. And I'll walk through this process. This demo is actually in a series of screenshots. I did that because I wanted to illuminate all of the Azure provisioning time from the talk. So we'll just go slowly through the screenshots. But this is complementary to HA and availability zones. And we built it at the request of a few customers who needed to demonstrate quarterly compliance that they could explicitly fail over to another region in Azure and then fail back as well easily and without making the app change. A few more things that we announced this week. It was a long list. Postgres 16, I already mentioned. Long-term backup retention went into preview. Independent IOPS scaling of PV2 v1 is now in I think we took this straight to GA. We did a new region in Italy, I believe. And then we added additional new Postgres extensions. We did the storage extension, which I referred to earlier. And we also did TDS FDW, which gives you a foreign data wrapper for connecting over SQL Server as well. There will be more. We'll keep pushing more extensions, both community extensions and ones that we build. But this was effectively the summation of what we did at Ignite this week. All right, let's get straight into some demos and make this a little bit more action-packed. The first demo is Postgres 16. It's the dullest demo you'll ever see. I didn't really want to start to get into writing SQL that only worked on Postgres 16. The main thing to know about this is that Postgres 16 is in the portal. You can go and provision it in Flexible Server today in any region around the world and start to play with it. Like I said before, to my knowledge at least, the only hyperscale provider who's got the official final build of Postgres 16 available in their service today. Okay, let's take a look at PV2. PV2, as we affectionately call it, or Premium SSD v2, has a lot of benefits to it. One, it has 4x the IOPS of SSD v1. Two, it has twice the maximum storage capacity of v1. Three, its units of scale are much, much smaller. You're no longer t-shirt sizing 2x, 2x, 2x in the size of the disk. You can move in gigabytes from very small out to 64 terabytes. The separation of IOPS and storage is already there as well. So what does it look like in the portal? Well, today in the portal, and I hope this is big enough for this screen, I tried to zoom it, you're presented with a new drop-down, which says Premium SSD. And if you expand that, you'll see that you've now got a choice of Premium SSD v2. So it's all just woven exactly into the existing flow. That's no problem. Now, when I choose Premium SSD v2, these are the defaults I get: 128 gigabytes, 3,000 IOPS, and 125 megabytes per second. Now, the weird thing is what's on the right-hand side, actually, because I just told you this thing has 80,000 IOPS, and what I didn't tell you, but it does have, is a maximum megabyte throughput of 1,200. But this is only showing a weird number of 68,719 IOPS max, and then 715. The reason for that is the maximums don't extend all the way to the smallest storage sizes. Now, a lot of databases are bigger than 128 gigabytes. But when I flip that storage size from 128 gigabytes to 256, as denoted by the green circle here, then my IOPS automatically changes and I can take it to 80,000, right? So you don't need to be too big to get the maximum IOPS. We do actually know some customers who plan to run relatively small sizes in the 500 or terabyte, 500 gigabyte or terabyte range, but absolutely are going to run 80,000 IOPS, right? That's just the nature of their workload. I'm sure we'll get the inverse as well and everything in between. I still have a problem with my megabytes per second though. As you would imagine, I move another number. In this case, I took IOPS and I dialed that up to 8,000. I didn't need to go all the way to 8,000 for this, by the way. But when I go to 8,000, then I have the full 1,200 megabytes of throughput available to me as well. Generally speaking, I think the vast majority of workloads will have the full spectrum of scale available to them, because what I've set these numbers to on the left they're not large numbers by any stretch. But in case you go back to your hotel or wherever you are tonight, and you go straight to PV2 to give it a spin and the numbers look less than what I just told you it can do, it's because you need to change some of these minimums to bring in the full scale. Okay, so let's look at a quick demo here. This is a 3-part video that I've taken the audio out of and I'm going to commentate. So the left-hand side, we've got split screen. Left-hand side is SSD V1 with the arrows pointing. Right-hand side is SSD V2. Left-hand side, 32 terabytes and 20,000 IOPS. Right-hand side, we're at 64 terabytes and 80,000 IOPS. And what we're going to go do is run this script. And all you really need to know about this script is that it's got an insert into statement where it's going to insert a single row. Then it's got a commit, which is going to flush it. So we're actually guaranteeing to create some IO pressure here. And it's going to loop over this thing 30,000 times to just bang down 30,000 rows. Right? Really simple brute force latency test. And so when we go run this, and actually went and finished, these are the numbers that I used on my chart earlier. You can see that the legacy PV1 disks, SSD V1, what's there today, did the 30,000 records. It took 44 seconds, and therefore the average time was close to 1,500 milliseconds. The exact same thing on the new disks was 25 seconds and 842 milliseconds. Now, this is not stretching those max IOPS numbers by any stretch. This is purely showing a latency measure. And in fact, if we set these to the exact same IOPS on each side, so disk 1 and disk 2 gets 20,000 IOPS and the same size and everything, you'll still see exactly the same numbers. So you don't control the latency. That's just a benefit of the underlying architecture in Azure. It's there, it's all built in. You don't need to do anything about it, but know that it's there. What I anticipate customers will be able to get out of this, existing customers, I expect may be able to reduce their storage costs, because we know that there are customers who are over-provisioned in storage to meet the IOPS requirements they need. That problem will go away. So you'll be able to tighten up your space, or you might be able to lift your IOPS sort of even further than you have them on V1 if you really need them. That's up to you to sort of optimize, but you've got the controls now that you didn't have previously, and all of these changes are online changes, by the way. So you're good to, I wouldn't say don't sort of go wildly experimenting on your production system, but certainly if you've got a dev test, you can move it around. It's going to be pretty malleable without needing to sort of continually restart things. Okay, let's move on to near zero downtime scaling. So with near zero downtime scaling, it's approximately 30 seconds. It could be a little over, but it will be nothing like it was previously. It applies to scaling compute, storage in the old disks, or both together, right? And so it's not it's 30 seconds no matter what. In fact, it'll be a little less for one or the other. So here's another demo, and I'll show you how this one works. Before I kick this off, the top, there's 3 panes here, and I'm sorry this one's a little bit small. The top left is going to run the scripts that change the compute size. So we're starting on 2 vCores, and we're going to run a script to change it to 4 vCores. The right-hand side is going to be a script that runs in a loop that's purely just trying to reconnect to the machine. And so that's interesting. All right, we're still going. And so we're going to start with 2 vCores up here. We zoomed out, which didn't help, right? On the right-hand side, we'll go start the loop. to the two vCore machine. And it's just going to connect, right? So you're going to see these successful connections over and over and over, and it just starts punching down the console there. The lower left is less important. It'll show you the script that we're running. It's just a little Python script that connects and iterates over these connections, right? So this is actually not doing anything. This is purely for illustrative purposes only in the lower left. But we'll go back to the top left. And what's going to happen here is we're going to go and scale the machine in a second. And when that machine scales, you'll see the right-hand side. This is the scaling operation. This is like making the call that you would make either when you're using the portal, or you're using Terraform, or you're using what have you, to change the size of the machine. Today, like I said, you're looking at about 10 minutes, give or take, and with higher variability on the timing. Now, we're making the scaling operation, so my connections are stopped down the bottom. You won't be able to see this, but I'll read the numbers off to you when the scaling operation completes. But it started to scale at 5 minutes and 26 seconds, and it finished scaling at 5 minutes and 49 seconds. So in that case, granted, this is recording, no hands, it was about 23 seconds of downtime to scale it. And it should be thereabouts, all the time. I think everyone here almost knows how to contact me. So if it doesn't, please let me know. Okay, so that's that one. Moving on. Azure Storage Extensions. So the way the Azure Storage Extension works is it enables you to load data using SQL directly from Azure Cloud Storage. Right? There are other variants of this or other clouds in the market as well. But basically what you can do now is you can go create or enable the extension Azure Storage. You can use the function here, which is account add, to specify the blob storage account that you want to load from, and it gets saved in the database as well. So you can probably tell there, you'll put an account name and you'll put a key in. And then you could just go insert directly from that file or folder or container directly into cloud storage. And so here's an example of what a slightly more verbose one looks like using a generic GitHub users sample. I just write my regular insert into GitHub users. I can write a select. I can write all sorts of transformations on that data as part of the select statement. There's no reason that I couldn't be nesting this inside a more complex grouping or window aggregates or anything like that and inserting it. But by and large, the number one scenario is just like, I want to load some data as is into a table and get to work on it. And so this is what that looks like. The number one piece of feedback we get from this one before anyone suggests, why don't you support Parquet, is that we need to support Parquet. We will get that done at some point in the future. Today, it is delimited files and compressed versions of delimited files, but I absolutely want to go get Parquet done. And so if that's something that we need to hurry up, please let me know. Okay, so let's take a quick look at Azure Storage. We'll break out of this and switch to real demo mode for a second. Let's see what I have to do here with PowerPoint. Need to extend here. Give me 1 second, sorry. It should be extending. Why are you not extending? That's going to be tricky. Let's try and blast that out again. Okay, I'm sorry about that. Let's go. So, starting at the top here. I've tried to zoom this, so hopefully it's good enough. We've got 4 extensions set up here. We'll get to the Azure AI one in the next demo, and that's going to take a little longer to get through. But you can see that we've got Azure Storage that we're ready to go use. Azure Storage gives me a set of functions. One is account listing, for example. So I've got 2 here. I've got the AZPG Storage Canary, and I've got a CF Storage one. You can see at the bottom as well. There's a whole bunch of things I'm not going to go do here. But what you can also do is you can list the blobs in your storage account. I've gone for TPCH in this example because I had it lying around. So I've got nation and line item tables sitting in my storage account. And so very, very simply, I'll just go drop my nation table. I'll go create a new one. And there's a little thing here. I want you to remember, I don't know if anyone's ever generated TPCH data using the data generator before. It's really annoying. It puts a pipe at the end of the last column. And so that means that when you come to load it, you need to handle that column delimiter and then the row delimiter as well. That's a little annoying. So one thing I've done here is I've just put the empty column there, which is going to catch this. And so I can go take a look at my nation table, and obviously it's going to be empty because I haven't loaded anything. That's fine. Insert into all these columns, select all this stuff. I've got some options here because I'm using a pipe delimiter. I'm giving it some columns, and we'll go run. So that's come from my blob storage account. I can go take a look at my nation table, 25 rows in nation, and we're done. So let's go do line item. The reason I wanted to make an example of that is one of the things that you can do with the loading, I'm going to scroll down a little bit here, is I actually don't need the empty column at all. Because what I can tell it is if I go create the line item table here, this is the proper defined DDL, there's no empty column here. If I scroll down, this is the whole insert statement. I still need to take account of mapping to that column, right? That empty column that's got that annoying delimiter on the end of the file, I still need to do it here. But in my select statement, I don't need to take it. I can take whatever I want. I can only take one of these columns if I wanted, as long as I've mapped them all out in that section below. So here's an example of me taking actually what's in line item, handling the broken delimiter as part of the loading process. And if I go ahead and run this, this is TPCH 1 gigabyte, so I think this is 750, line item is about 750 megabytes in this model. It takes about a minute 20 to load. We can come back to this in a second. But it loads 750 megabytes in about a minute 20. It's using the copy infrastructure under the covers to load this, which is really quite performant actually in Postgres. And you'll end up with about 6 million rows, which I commented at the bottom there to save us hanging around for the full 1 minute loading. We will come back to this, but let's keep moving just for the moment. So that was Azure Storage. It's there, it's available globally as well. I want to talk a little bit about this multi-region disaster recovery that we've shipped as well. So in multi-region DR, you've now got the option to do a manual failover, which is either planned or forced. The difference is really simple, data loss. When you're doing data replication across regions, it is asynchronous. You can replicate from North Europe to West Europe. You can replicate from East US to Australia, which is almost flip side of the planet stuff. But we put it under a single virtual endpoint. Now, I'll walk through the whole end-to-end creation experience in a second to give you a real context. But there are some subtle details that I just want to point out here. The light blue on the top right and the lower left, that's the writer endpoint of the virtual endpoint. So the virtual endpoint actually has two names under it. It's got writer dot and then your name, or reader dot and then your name. We handle flipping that when we do the failover. So when I do a failover, my writer starts to point to my new primary, which is in the other region down here, and my reader goes in the other direction, right? This is the important thing. So no change in the app. Today, or until we did this feature, you had the option to promote a replica, but it did a couple of things. One, when you promoted it, you lost the replication, so that was a problem. But secondly, you had to go change the connection string in your app, right? Now you don't need to do that. And so you can fail these things over either planned, and if we do a planned failover, then we will drain the replication queue before we fail it over. So it's asynchronous, but we still won't leave any data behind, if you will. Forced, we'll just force it. We'll fail it over, and if you've got some that hasn't replicated yet, it's going to be stuck on the primary until you go get it. So let's sort of walk through what this looks like. These fonts might be a little small on the screen, I'm sorry, but I'll sort of explain it, and I've got some red boxes which will show you what we're clicking on here. So on the left-hand side, we have replication. And we'll go click replication, and we have this new interface where I'm presented with virtual endpoints, which is the top section, and then servers at the bottom. And so this is a vanilla flexible server that I just created. There's no virtual endpoints. There are no replicas anywhere. godr.postgres.database is the one server that I literally created about 4 minutes before I took this first screenshot. And so I'm going to go and create the virtual endpoint first. And so here I'm going to give the virtual endpoint a name, which is godr EP endpoint, if you will, in the top right-hand corner. And I'll go ahead and hit create. I can't change the reader server down here, by the way, at the bottom of this pane, because I only have one server. So that's what it's going to be. So we go ahead and hit create. And this will go ahead, and this is why I screenshot this, because I wanted to eliminate the provisioning time for doing some of these stages. But we'll get that standard Azure portal notification where my endpoint is being created. And at the end of this, I have a virtual endpoint. And that virtual endpoint in the middle says godrep.writer.postgres.database and godrep.reader.postgres.database. You can go and put these connection strings into your app right now at this point. Now you need to know that the reader can only accept, select statements, and the writer can select everything. But once those things are hard-coded into your app or configuration files or whatever you want, you're good to go. So now I want to go and create a replica. There was a small UX bug when I did this, which is why it's grayed out, but trust me, you can go click it today. And it presents me with another provisioning UX, slightly simplified from the main primary one, where I can now go and create the name of my replica server in a different region. And so in this case, I did godr-repl. And I go through and hit review and create, and that goes in provisions. Again, that took a few minutes. And now we have our virtual endpoint at the top, setting up so we've got a single endpoint to fail over across regions, and we've got flexible server primary running in one region, and flexible server running, in this case, actually it's in the same region. I put it in an EAP region, which we use locally, but trust me, you could do this across regions as well. So now I have a small problem, as the slide reminds me. I have my godr server, and I have my godr-repl server that I want to fail over to, but if you look at my virtual endpoint, they're both pointing to the original server. This happens for one reason only really, the order of operations with which I created things. I created the virtual endpoint first, and then it looks to see what servers I have, and it propagates them to both the reader and the writer. And then I created the replica server, and it doesn't retroactively apply that. The good news is I can go ahead and just edit this now. And if I click on edit, now my drop-down that I told you had no options before, because it didn't, I can click on that, and I can say that I want my reader to be this geo-repl box that I just set up. So we'll select that and hit save, and again we go through a little provisioning process. And now my writer.postgres is pointing to godr Postgres. My godr-repl is my reader, but note that the prefix of my virtual endpoint, that thing that I created, that's not the server name for either my primary or secondary. It is a virtual endpoint. Once upon a time, if you ever did like Windows failover clustering and you had like virtual IPs, quick little throwback to that, same concept. Virtual IP that will route to either which one is active. And so now we're good to go. And so now we can go ahead and hit this little button down here to promote. And then we click this, and we get this new UX on the right-hand side. And it's given me a few options. The action is to either promote to the primary server, which is the new feature that we're talking about here. And when I go do this, it effectively just reverses the direction of the replication and starts pointing back to my existing machine as the new reader. Or the existing feature that we had already, which is to promote the replica to a primary, and that just breaks all replication and makes it a standalone machine. The other option I have is sync. I can either do planned, which I described earlier, means we will drain that asynchronous replication queue and then fail it over, so you get zero data loss. It does mean that we need to stop taking incoming data from the app into that writer endpoint. So depending on how hectic your app is, there could be a little bit of variability there. And then when we do the failover, though, we bring it all back up and you've got all of your data. Or you could do a force, which is like, we'll just fail that over. But like I said before, anything that hadn't been replicated will be left behind. It will be committed to the primary. It just won't be pushed to the secondary. Okay, so we go hit promote. Oh, there's my little zoom. I forgot that I had that one. This goes through its process now. And when this finishes, my roles are reversed. That godr.postgres has become my reader, and that godr-repl, which I set to be my reader before, is now my writer. If my app is running, it's a console app, it's a Windows form app, it's an anything app, and it's pointing at Postgres sending transactions, you have not touched it. In fact, for all intents and purposes, if there's another team that's responsible for the app and they're maintaining the app, they've noticed a slight blip in traffic and everything continues as it was. Meanwhile, your primary database is now on the other side of the planet and it's running happily. It's reversed the direction of the replication back to the original primary. And at any point, you can just run the exact process that I ran and flip it back again. So this was, as I mentioned, inspired by DR drills from customers that we were asked to build. And there were really clunky ways to get this done previously, but we think this is a great, slick way to do GeoDR, complementary to high availability, which is a synchronous replica across availability zones within a given region. So one is really HA. This is, think of this more as a DR capability as well. All right, let's get on to Azure AI, where probably I think we've seen the most excitement, not to take away from HA and DR. That stuff's all cool and super important, but obviously AI has been in the news a fair bit this week. What this enables you to do, as I mentioned at the top of the session, is use the same extension, SQL-based extension interface to create and return embeddings from Azure OpenAI. Right? Postgres has had an extension called pgvector for quite a while now. And it was really good, still is really good, we ship it, at storing and indexing vectors. But if you wanted to create that giant decimal string that I showed you, that was all at the application layer. Right? I had to have an app that would go to my database and select some text back and return that. Then it had to bundle it up into a call and ship it over to that web service to generate the embedding. And then it needed to get that back. And then it needed to bundle that into an insert statement and send it down, or figure out what it was comparing against if there was like a search term. It's not scalable at all if you're doing like a large scale search. And it adds a lot of latency to that end-to-end execution of that query. The other problem, of course, is that that's the bit of one app. Right? If you've got sort of multiple apps, or however you architect your apps, see on top of the databases, they'd all sort of need this functionality built in, or you'd have a separate component for it. Pushing it all down into the database is really nice. And so what Azure AI does is it gives you that embedding creation capability to complement pgvector. And so you'll see in a lot of the stuff we write, Azure AI complements pgvector. Azure AI will do the call to get it. pgvector will store it and index it and give you the query operators like cosines to do the semantic search, which we'll look at in great depth in a second. So here's what that looks like. Create extension Azure AI, we've already got set up. There's a couple of settings that you give it. So when you run this with Azure OpenAI, we're not bundling that into Flexible Server for you. You still need to go and create your own instance of Azure OpenAI, and then you need to go get that endpoint, bring it back and set it in Flexible Server, just like you would the key for a storage account for Azure Storage. And then to run it, it's a simple function of create embeddings. And so here, Azure OpenAI, create embeddings. I give it the name of the model. We'll use a different one in the demo. And then there's a text string in there as well, which we would return that giant decimal-based string that I showed you. Okay. And here's the skip ahead to what the embedding looks like. So let's get into a more sort of significant demo for this one, and see what we can do here. And we'll go back to okay, there we go. All right. By the way, my line item table finished minute and 9 seconds. It says at the bottom there, for anyone who was keeping track. So about 70 seconds to load 6 million records and about 750 megabytes. So what's that? About 10 seconds or 7 seconds per 100 megabytes is pretty slick. Straight out of cloud storage. Any storage account, you can load it from the other side of the planet if you want it. Azure doesn't really split hairs. Okay, let's get into Azure OpenAI. So what I'm going to show here is basically walking through an example of doing semantic search But I want to show you the way that we've all done it in the past. I'm pretty confident that every single person in this room at some point in time has written a SQL query. You will have written the bad ones that I'm going to go show you, and then we'll get onto semantic search and show you why this actually really matters. So I'm going to use Dem 126, which was the demo session that I ran, the same demo at Ignite. I think I have the liberty to run the same demo at 2 different conferences in the same week, so I'm going to go do that. And then I'm going to go and create this new table, Dem 126 recipes. You'll notice this table has got 5 columns. We're not too phased about the first and the 5th one, but the middle 3, title, ingredients, and direction, are all text-based columns. And they are the subjects of our demo that we'll be walking through over the next 250-odd lines of SQL. So I create a table. Table's empty, obviously. Let's go load 500 recipes into this table. So that happens incredibly quickly because I've got another table in the database that has my recipes in it, but this is just for loading it up. And so what we would expect, of course, is that I get 500 rows back, as denoted in the lower left-hand corner, and we've got some text, which is the title, the ingredients, directions, etc. This is pretty much the most that I thought I could zoom pgadmin to make it readable, so hopefully everyone's sort of following along. So we're going to do a couple of things here. I'm going to go look. My intent here is to find high-protein meals. Chicken is a high-protein food. Salmon's pretty good as well. Beans actually happen to be pretty good as well. But what I want is high protein. That's the diet that I'm on, or I'm at this recipe website, and they're the meals that I'm looking for. So we'll go ahead and we'll do what we've all done a zillion times before. We're going to go pattern matching for chicken, because I know chicken has protein in it. So let's see what I can go turn up here. So we get a whole bunch of results back. It's useless though. How do I order this? I can't do anything with it. So then we'll go through and we'll look at chicken in multiple columns. Well, obviously I'm going to get more rows back there as well. I got lots of chicken. That's great. But it's still not actually helping me with what I want. So let's go look for what I actually want. My high protein meals. Obviously there's nothing, right? No one's going to write high protein meal into a title or a direction or in anything, right? So this is where the system breaks down, right? And this is where semantic search is sort of fundamentally broken down in any number of relational databases to date, because I have this intent, but I can't solve it with basic SQL operators that I've always been able to access. So now we'll try full text search, right? Full text search has been around for a long time. I can tell you it's not going to help us much. So we'll take a look at our table where I added a column actually on the right-hand side here, which shows that I've now got a full text search column and a full text search index. So let's take a look at this one. Can I find any chicken? I had 56 results before. Now I have 57, which probably means chicken was in the directions as well, but still not really doing anything for me. So what do I need to do here? Well, we could try high protein recipes, but this obviously isn't going to do anything either. So let's see what Azure OpenAI can do for us. So I showed you on the slide before. I won't run that query to show you the extensions. Trust me that it's loaded. But here I could run, I need 2 extensions that I'm going to use. The Azure AI extension is what gives me that interface out to Azure OpenAI where I can send data. And then vector, of course, is where I'm going to store, gives me the type, gives me the index, gives me the operators to the comparisons. So I've set this up ahead of time, obviously. We'll go check what's in my recipes table. I've got 500 of them. Now I'm going to go alter this table. And this is something you did not see in the keynote because it takes about 30 seconds. And I'm going to run this. This query takes about 30 seconds to run. And what it's doing is it's taking each row from that recipe table, 500 rows, it's sending it to Azure OpenAI, getting the embedding, returning the embedding to the database, and storing it in a vector column, which is what I'm creating here. And so if you walk this code, alter table, we all understand that, add column recipe embedding using that vector type, and this is a generated column. So now I'm going to have all of the embeddings. That crazy long numeric string that I showed you has been generated 500 different times, and it's stored in the table. This is where volume of data will start to show up. My recipe table has 5 columns of data, and I've just added however many more bytes of numbers to it. So you will see this in your storage usage. But now, actually, I can go see if it's been stored, and I'm just going to take 2 columns in recipe embedding, and sure enough, here are our huge numbers, which we just looked at on the slide, 1 for each row. Okay, thank you, Azure OpenAI. There was a cost to this. The cost was the request cost for Azure OpenAI as well. So everything that, from a pricing perspective, from an interface perspective, all of that's public, and that's exactly what we're using here. We're just giving you the interop from Postgres into it. So now, let's go take a look. I mentioned that we've got PG Vector 0.5.1, actually only shipped about 4 weeks ago or so. This was a real rush effort to bring in for Parse and Ignite. I was pleased to get that done. And now we'll go create an index. HNSW is one of a couple of indexing techniques in PG Vector now. Now, I'm going to digress for a second. Because what I showed you previously for creating these embeddings was a generated column, which means that in future, every time I insert a recipe, I will automatically, as part of that insert, call out to Azure OpenAI and bring the embed. There are some inherent risks with that as well, which we can be very sort of clear about. If for some reason the connection to Azure OpenAI is not there, for whatever reason, then that insert will not happen, right? So when you're actually building these applications, you may want to be a little more careful sometimes that you make sure that recipe gets committed, and then maybe after the fact, asynchronously, you'll make a call to go get the embedding and populate it in a slightly more resilient way. The last thing you want is for a critical transaction from a mission-critical app to not be written into your database that's got high availability and everything configured because a separate service over there has got an unexpected latency or temporary outage or something like that. So that's just my hot tip on application design. What I want to show you, though, I'm just going to get through a couple more statements here, is actually we'll do the insert first, that's right, is I'm now going to go insert a new recipe. So remember, it's 500 recipes in my table today. I'm going to insert, and the reason I commented these on the left-hand side, the comments for title, ingredients, directions, and URL, was to be very explicit so that you could see I'm not inserting an embedding. I'm not calling for the embedding. I'm treating it like this, like the most rudimentary insert statement that you possibly can in a database. And so we'll go run this. The good news about this is that this insert just made the call to Azure OpenAI, got the embedding back, wrote it in. This transaction still only took 174 milliseconds. So the response rates for these things from Azure OpenAI are very, very good. The performance I don't sweat as much as just making sure you've got that guaranteed reliability in the app. We'll go check that we've got 501 rows. Yes, of course we do, because we've been watching it. And if I go look at the one row that I just inserted, which was oatmeal breakfast bars, you can see that the embedding is being created there. And that's purely because I used that generated column and it made the call to Azure OpenAI. But it's demonstrating that call was made. Okay, so here's my quick tangent that I thought I was going to make earlier, that you could do this with anything. It's not just generated columns. I haven't picked sort of the happy path here. Let's go do just a rudimentary update as well. So I've got another table here, Dem1 in 26 recipes update. And we'll go drop that one. And then I'm going to go recreate this. And this is the whole table, right from the beginning. I'm leaving out the full text index. I think we've ruled that one out at this point. But I am bringing in the recipe embedding column, which I didn't create at the top before. Now, we'll do the same thing again, the same insert statement that I ran. You can see it all commented. I told you we had a couple of lines of SQL. We're down to about 180, 190 now. And so this table's got one row of data in it. And this is it, right? Everything I just showed you, except the embedding's missing because it's not a generated column. Really, really rudimentary stuff. Now I'm just going to run a basic update. And I'm going to say update, my recipes update table, set this column to, and then here's the call. So I want to pause here and just sort of walk this code a little bit so you can see exactly what's happening. Azure_OpenAI is the schema name within the extension, right? And we'll get to the other one shortly. Create embeddings is the function that takes 2 parameters. The first is text embedding ADA002, which is the model that we're calling in Azure OpenAI. The second is a concatenation of the title, ingredients, and directions columns. So I'm taking all of that text, just jamming it together, and I'm sending it off to Azure OpenAI and saying, give me the embedding back, right? And so if I go run this, 177 milliseconds, so we're consistently under 200 milliseconds for Azure OpenAI. And then we go run the same query. There's my embedding, right? This is really simple stuff, but I just want to show you that you've got full flexibility for DML that you'd expect doing this as well. All right, so now let's see where the rubber hits the road. We'll try again to get title and ingredients from the recipes table where it's high protein recipes, which is down here. But what are we doing here exactly? Well, this sign here, which is perhaps not too familiar to folks, is for the inner product in pgvector. And so what we're doing here, you imagine this is a search query. Imagine it's a website, got a text field at the top, and I've typed in high protein recipes, go. What's happening is we're saying, give me a couple of columns from a table where that column has the nearest, because it's an order by, the embedding there is effectively the nearest to whatever the embedding for this string is. So what's happening here, the order of execution is basically, go run this first, Azure OpenAI, give me an embedding, right? Then, go compare that embedding to every single one in this column from this table, there's no where clauses or anything, and then order it to the nearest match, effectively, and just give me the top 20. So high protein recipes, we got 0 results for high protein recipes in any configuration we tried earlier in the demo. What do we get now? Now we get our oatmeal breakfast bars, and we get our beans, and we get our chicken, lots of chicken, seemingly lots of chicken, high protein stuff, right? Makes sense to me. This is semantic search. This was my intent. My intent was high protein meals, and I got back high protein meals. Now the ordering is a little subjective here, right? That's sort of the nature of the technology, but it's definitely better than anything I could do previously. There's another symbol, cosine distance. It's actually going to give me, in this case with the top 20, by the way, it gives me the exact same thing. But if you're looking for a little bit of light reading on the way home, a bit of reading on pgvector and the types of comparisons it gives, inner products, cosine vectors, might be an interesting topic. So I did high protein recipes. Let me show you what's actually happening here, by the way. I've got title, ingredients, high protein recipes, and then this is sort of a little clunky here. This is actually part of my select statement now as well. And so because I alias this to inner product in my select statement, I can use the alias in my order by clause. So it looks super similar, but what you're going to see here is the actual result of the comparison. And that's on the right-hand side. So the negative 0.81168, that was the best match, right? So you can see the result of the calculation that's happening as well if you want. Goes well with chips. What goes well with chips? Anyone? I can't remember. Dip? The answer's dip. I'll tell you ahead of time. It's dip. And it works, right? So, play with it. See what you get. It's not always absolutely perfect, but it's very, very good, right? And embeddings are, for all the ChatGPT stuff, the chatbots and everything, these are one of the foundational components, and it shows how we can really light this up very nicely in Postgres for doing this semantic-based search, pure SQL. I've written SQL for as long as anyone probably in this room. That's the place I go. I feel comfortable. The fact that I can now hook into this without needing to write Java and C# or anything into these API endpoints makes me feel very warm inside. Okay, so here's the other thing. We didn't only do Azure OpenAI. We also did what was formerly cognitive search, and now I think is Azure AI Language or Azure AI Search. I think its name was changed. Language, thank you. And so let's go run this. And what this does actually is it shows me all of the functions that we support for the cognitive schema. So Azure OpenAI. So the Azure AI extension is the thing. That's the extension. Within it, you've got Azure OpenAI, which I just demonstrated north in the script. And southbound, we've got Azure Cognitive as well. And so we're going to look at a few of these functions. We'll go drop the recipe reviews table, and we'll go create a fresh one. And it doesn't matter what this common table expression does. It's not fancy, I'll tell you. It's just hard coding 4 rows with very intentional sentiment, and I'm putting them into that table. So now I'm going to run reviews CF, 4 rows. Really, really simple stuff, but let's see what we can do with this. Well, the first thing we can do is sentiment. So I'm going to go take my recipe reviews CF table, and I'm going to call Azure Cognitive Analyze Sentiment. There are some ways you can control what comes back to sort of clean it up, but here I can see positive, negative, neutral, positive sentiment of the text in those strings. Now, if you're running queries to serve results back to apps, I would probably not advocate to be calling the cognitive search every time. These strings are fixed. So once they're stored in the database, go get the sentiment, store it in another column, or if you want to get into data modeling, have a sentiment table with key 1, 2, and 3, and put your sentiment keys in there, whatever's your preference. But generally, I think you want to be minimizing the traffic. It will create cost. It will create an unpredictability in the cost as well. So run once, store forever is going to be a more efficient way to do it. We can do language detection directly in Postgres. This one's English. This one, as I recall, was Portuguese. And the next one was German. Again, if you've got an international website, people are typing international comments in it, you want to know what the language is because you don't know anything about that customer, by all means, go ahead and use some of these capabilities. And then finally, recognizing PII, as we showed in the keynote as well, enables me to strip out sensitive data also. So this is all there today. I didn't go through the full expansive set of what's in cognitive. But the key thing, I think, and the critical takeaway here is that it's all just SQL, right? You light up these extensions, go take the samples from all of the docs, we'll keep writing more samples, and all of a sudden, coming back to that theme that I said at the top for developers, you've got these integrations to Azure Storage, you've got OpenAI, you've got cognitive. We'll keep doing them. We want to know what they are and where the gaps are. But the extension model in Postgres is just beautiful. Like, it enables us to ship these things very efficiently and ship them, put them into flexible server very, very quickly as well. Okay, I've moved relatively quickly because I wanted to make sure we got through everything. So I will wrap it up right here. We will continue to build for developers and enterprise, right? I showed some things around developers towards the end. We did some demos around like high availability and GeoDR for the enterprise as well. They are not mutually exclusive. They absolutely overlap in pretty much every sense. My position is it depends where you start. If you're migrating an existing production app, that would put you in the enterprise bucket, even if you're a developer doing it, because you need to move to a platform that has the security, availability, and reliability, and everything like that. If you're a developer on day one of a net new app and you just want some cool things and some good integrations to build something new, that's where we'll continue to invest as well. All of those apps will one day need enterprise requirements for production deployments. Every enterprise employs developers who want to build new stuff. It's a very overlapping world, but I think if we continue to focus very distinctly on these two pillars in flexible server, we can serve the totality of our customer base. And for us, always, the trick is just to make sure we're prioritizing the right things at the right time and keeping folks unblocked for the next big thing that they want to go do in the service. So with that, I will wrap it up. Thank you. Oh, yes, we do have plans for 2024. We're not going to get into that right now, but next year's not too far away. So that's the wrap. I think we do evaluations. We do. Evaluations are always welcome, either in the system or just come up and tell me. I've got one question. Yes, sir, go ahead. Yeah. So the question for the recording is there any extra cost for using the extension? There is. The cost is whatever the supporting service costs. So it's I think it's a cost per request to Azure OpenAI, for example. So for those 500 requests I made to populate that table, yeah, I'll pay those 500 requests to Azure OpenAI. But the extensions themselves are all built into flexible server. There's no cost. There's no cost there. Just like the file I loaded from storage, I'm paying storage cost against a storage account, but the extensions themselves, no. They're all completely bundled into the flexible server price. All right. Thank you very much. Late on a Friday. Thanks for coming.